bringing technology and precision together. This project delivers a flexible analog monitoring and testing platform, perfect for sensor calibration, industrial control panels, laboratory test rigs, or even classroom demonstrations. To prove it's more than theory, we even connected a simple LED to one of the DAC outputs and watched it fade smoothly as the DAC voltage changed. A quick eye-catching demo that shows that signals are real and ready for action. At the heart of the setup is the clicker for STM32F7 dev board with a built-in code grip programmer debugger running firmware built in NECTO Studio. 4 microbus sockets give us everything we need. On microbus 1, the vivid IPS display 2-click shows real-time readouts. On microbus 2, the DAC 12-click generates a precise voltage outputs. On microbus 3, the ADC 14-click captures the first analog input, while microbus 4 hosts the ADC 15-click for a second measurement channel. The wiring is straightforward. DAC outputs are routed to both ADC boards, out 0 to ADC 14 and out 1 to ADC 15, with a common ground to keep signals stable. This lets us sweep DAC voltages while both ADCs measure the response in real time. All results appear instantly on the IPS display, showing DAC 12 voltage, ADC 14 voltage, and ADC 15 voltage side by side, so system accuracy can be observed at a glance. Complete instructions and ready-to-flash code are available on Embedded Wiki, making it easy to reproduce or expand this test platform. With NECTO Studio, clickboards, Embedded Wiki, and the reliability of MikroElektronika hardware, we can build professional and analog solutions fast.